So for this problem, we need to go ahead and we need to graph f of x equals -2 times x plus 3 times x minus 1. First off, we need to identify our x-intercepts. So our x-intercepts are that p and q. So p in this case, looking at the form of x minus p and x minus q, that would give us a -3 for p, and for q, it would give us a +1. Remember, it's the opposite of what you think in the parentheses because it's in the format of x minus whatever the value is. So I have an intercept at -3, 0. I have an x-intercept at 1, 0. I am going to use those for graphing. Now, the next thing I need to do is I need to go ahead and find my vertex. My vertex is found by p plus q over 2, and then I plug that back into my function, and then I get that output. So let's go ahead and try that out. So to find p plus q over 2, that's -3 plus 1 over 2. That gives me -2 over 2, so I have a -1. And that is the x value. So now I need to take that -1 and plug it back into my function to get my output for my vertex. So that's -2 times, and then -1 plus 3 times -1 minus 1. That gives us -2 times 2 times a -2. And what is that? That is a +8. So our vertex is -1, 8, and we have our p and our q. So now we can go ahead and complete our graph. So I'm drawing my axes. Now, I see that I have to go all the way up to 8 on my y value, so I'm going to draw my axes a little lower just so that I can go ahead and properly graph those pieces. So -3, 0, and 1, 0, and then -1, and then count up to 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then over to that -1. So that's going to go down, and then that's going to go down. So you want to make sure it's facing down. Now it's a little sloppy because I'm on my iPad, but on your guys' paper it'll be a little better of a curve. And then you can see that that's the axis of symmetry at x equals -1. And that right there is our graph. You actually don't need to graph or plot 5 points on this one. We'll just go ahead and take it with the vertex and the two x-intercepts. And that is it.